Right now, particles in your body are doing something absolutely impossible. They're existing in multiple places at once. They're communicating faster than light. And the very act of you watching this video is changing reality at the quantum level. Sounds like science fiction, right? But quantum mechanics is the most tested, most accurate scientific theory we've ever created. And it's completely bonkers. I'm going to show you 7 quantum facts that will fundamentally change how you see reality. And I promise, no complicated math, just pure mind-blowing weirdness. By the end of this video, you'll understand why Einstein called quantum mechanics spooky, why physicists in 2026 are building computers based on these bizarre principles, and why reality might be way stranger than you ever imagined. Let's dive into the quantum realm. Fact number 1. Particles are also waves. Both, at the same time. This isn't a metaphor. Electrons, photons, even entire molecules act like solid particles and spread out waves simultaneously. We discovered this through one of the most famous experiments in physics, the double slit experiment. And trust me, this one will mess with your head. Here's the setup. You shoot particles like electrons at a barrier with 2 slits. Common sense says each particle goes through one slit or the other, right? Like throwing baseballs through 2 windows. But that's not what happens. Instead, you get an interference pattern on the detector screen. The same pattern you'd get if waves were passing through both slits and interfering with each other. Here's where it gets weird. This happens even when you shoot one particle at a time. Each single particle somehow goes through both slits simultaneously and interferes with itself. But wait, it gets weirder. If you put a detector at the slits to see which one the particle actually goes through, the interference pattern disappears. The particle suddenly acts like a particle again, not a wave. The act of measuring changes the outcome. Reality literally behaves differently when we're watching. This brings us to fact number 2. Superposition. Quantum particles exist in all possible states at once until you measure them. It's like a coin spinning in the air, being both heads and tails simultaneously. Except unlike a coin, which is definitely one side even while spinning, a quantum particle genuinely isn't in a definite state. It's in a mathematical combination of all possibilities. This is the basis of Schrödinger's famous cat thought experiment. Put a cat in a box with a quantum device that might release poison. Until you open the box, the cat is both alive and dead. Now, Schrödinger proposed this to show how absurd quantum mechanics seemed. But here's the thing. At the quantum level, this is exactly how reality works. We don't see cats in superposition because larger objects interact with their environment constantly. Those interactions collapse the superposition almost instantly. But for isolated quantum particles, superposition is perfectly normal. In fact, quantum computers in 2026 use superposition to perform calculations. A quantum bit, or a qubit, can be 0 and 1 simultaneously, processing multiple solutions at once. Companies like IBM and Google have quantum computers with over 1,000 qubits now. They're solving problems that would take classical computers millions of years. Fact number 3. Quantum entanglement. Einstein called it spooky action at a distance. And honestly, that's the perfect description. When 2 particles become entangled, they form a connection that persists no matter how far apart they are. Measure one, and you instantly know something about the other. And I mean instantly, faster than light. In fact, experiments have separated entangled particles by hundreds of kilometers and confirmed this connection happens with 0 delay. Now, before you ask, no, you can't use this to send messages faster than light. The results of measurements are random, but the correlation between entangled particles is perfect and instantaneous. Einstein hated this. He thought it meant quantum mechanics was incomplete, that there must be hidden variables we're missing. But experiments proved Einstein wrong on this one. In 2022, the Nobel Prize in Physics was awarded for proving entanglement is real. And by 2026, we're using it for quantum encryption that's theoretically unhackable. Which brings us to fact number 4, the uncertainty principle. This one is often misunderstood, so pay attention. Heisenberg showed that you cannot simultaneously know both the exact position and exact momentum of a particle. The more precisely you measure one, the less precisely you can know the other. This isn't because our instruments aren't good enough. It's a fundamental property of reality. Position and momentum are complementary properties that can't both have definite values. Think of it this way. To measure a particle's position precisely, you need to hit it with high-energy light. But that high-energy light changes the particle's momentum unpredictably. The uncertainty principle means that at the quantum level, reality is inherently fuzzy. There's a fundamental limit to how much information you can have about a system. Fact number 5. Quantum tunneling. Particles can pass through barriers that should be impossible to cross. It's like throwing a ball at a wall and occasionally having it appear on the other side. This happens because particles don't have definite positions. They're described by probability waves. Even if a barrier looks impenetrable, there's a tiny probability the particle exists on the other side. For big objects, this probability is so astronomically small it never happens. But at quantum scales, it happens all the time. In fact, the sun wouldn't shine without quantum tunneling. Nuclear fusion requires particles to get close enough to overcome electromagnetic repulsion. But they don't have enough energy. They tunnel through the barrier instead. That's how stars work. Fact number 6. Quantum decoherence. This explains why we don't see quantum weirdness in everyday life. It's the reason your car doesn't exist in superposition while you're not looking at it. Large objects constantly interact with their environment. Air molecules light heat. Each interaction entangles the object with the environment, destroying quantum superposition almost instantly. That's why quantum computers need to be isolated at temperatures colder than outer space. Any warmth or vibration causes decoherence and ruins the quantum calculations. Fact number 7. Quantum mechanics is non-local. Information about a quantum system isn't stored in any specific place. It's distributed across the entire wave function. This means the universe doesn't work like a computer with information stored in specific locations. Quantum information is fundamentally holistic, existing everywhere and nowhere until measured. So what does all this mean? It means reality at its deepest level is nothing like our everyday experience. It's probabilistic, non-local, and observer-dependent. And that's not philosophy. That's physics. The good news is you don't need to understand the math to appreciate how revolutionary this is. And in 2026, quantum technology is moving from labs into the real world. This isn't abstract anymore. It's our future. If your brain hurts right now, good. That means you're getting it. Even physicists find this stuff weird. If this blew your mind, do me a favor and hit that like button. Subscribe for more videos that make the universe feel less impossible. And remember, quantum mechanics isn't just weird. It's the most accurate description of reality we've ever discovered, which means the universe is way stranger and more wonderful than our everyday senses tell us. Keep looking up.